Okay, so let's take a look at the midpoint rule for Riemann sum. We're still looking at the same function, x squared plus 3. I'm still going to look for the domain 0 to 4. 1, 2, 3, and 4. If I graph the function, we're still starting at 3, ending way up here at 19. And so there's my graph. Wow, it's getting a little stretched out there. Now, we're still keeping our delta x equal to 1. The change in x's. But the midpoint is telling me in the middle of each partition, I'm still partitioning it, I'm still going to make my rectangles, but instead of picking the left or the right, I'm going to pick the value in the middle. And so you got to be careful because you will most likely have to deal with fractions here. So I pick the middle of each one of those little segments. And from here I can make my little rectangles. Well, the area of a rectangle is still the same. It's still going to be this delta x times some height. I get the height this time by looking at the function. F of 1/2 in this case. In other words, still f of x. The area of a rectangle. Length times width. So you get the area then. For my first one, it's going to be the value at 1/2 times the width, the delta x, 1. For 3/2, so plus, do the same thing for 3/2. We're going to get f of 3/2 times 1. And I do the same thing for 5/2. So I get plus f of 5/2 times 1. And then for 7/2, plus f of 7/2 times 1. Now, I notice every single one of them has a 1 in common. And I find the values. Now, I've already done this beforehand, so the value, if I plug 1/2 into the function here, I get 3.25. 3/2, if I plug it into the function here, we're going to get 5.25. 5/2, plugging it in, we get 9.25. And 7/2, 15.25. I meant a quarter, I think it said halves there. And if you add them all up, you're going to get 33 units squared. And there's a midpoint area. Now, because this part of this is over and under estimate, we see that this is normally the best estimate. Now, we're going to spend a little bit of time determining how we determine something an overestimate or an underestimate. And that's what we're going to talk about right now. Now, in order to do overestimate or underestimate, we have to look at two things. One, the shape of the graph, and two, which side are we doing? Are we doing a left hand or a right hand? So let's deal with the left hand rule. If I'm dealing with the left hand rule, let's talk about the function. I have a decreasing function and an increasing function. In a decreasing function, from A to B, ready? If I just kind of sketch this, if I want to find this area, the left hand, I'm going to choose A. If you notice, we have this little part above here, the function, right? This is an overestimate. So if it's a left and decreasing, we have an overestimate. What if it's an increasing function on the same domain, from A to B? Well, let's take a look. An increasing function. If I pick from A to B, this is terrible. This is not the best one. Let's try it like this. There we go. From A to B, take a look. By picking my left, I have this whole big space here that's open underneath it. That's an underestimate. So if it's left and increasing, it's an underestimate. And you can even change it around, make it concave down, concave up, play around with it. Now, let's talk about the right hand. Okay, if we look at the right hand, let's again look at a decreasing function and an increasing function. In a decreasing function, look, another decreasing function from A to B. If I look at the right hand, that's the B. Now take a look. I have an underestimate. So if it's right and increasing, oops, sorry, not right and increasing, decreasing, we have an underestimate. If I look at an increasing function, Now we're talking about increasing. We're not talking about the concavity. We're talking about the slope itself. The slope is increasing from A to B. If I look at the right-hand side, take a look now. Choosing the B because it's on the right side, I have an overestimate. So if it's right and increasing, we have an overestimate. So there are 4 things we need. Okay, so take a look at those. Okay, and we'll see you guys in class. Bye.